Okay, today we're going to talk about dividing monomials. This is our topic. All right. So before we get going here, let's do a simple example. So let me try to. So if I had a monomial, you see AC is a monomial, is that right? Over BD, that's not a monomial. So we're going to be doing something like this. But is there a way to rewrite AC over BD as product of two fractions? Yeah.
AC over 1 times 1 over BD.
Well, I guess you could do AC over 1 times 1 over BD. Yeah, sure. Also, what if could I write it as AB over something? AB times what? CD. Yeah, that's what I meant. Very good. Yeah, and of course you could do it that way. Yeah, you could do AC over 1 times 1 over BD, same thing. But you could separate it as A over B times C over D. By the way, monomial means how many terms? One. How many terms do I have on the numerator? One. How many terms do I have on the denominator?
One.
Because terms are separated by an addition sign. Very good. Okay. So if this is true, I have to write this also. What do you think I need to write? B can't be 0, D can't be 0. Yes, Samuel?
Because if either of them are 0, then the
Entire thing is undefined. Good. If either one of those are 0, then the whole expression will be undefined, right? So you have to write those down. Okay, is that okay? All right, so if this is true, let's see what we could do with this fact, okay? So our first example here, simplify 15 over 21. And many of you probably know how to do this already. And what would you do to simplify this? Divide top and bottom by 3. Okay, now, but is there a way to do this problem a little bit differently? Looking at that fact 1? Yes, Dana? Exactly. Can I write this as 3 over 3 times 5 over 7? Right? Well, we just told you that we could rewrite them as, right, product of two fractions, right? What is 3 times 5, class? 15. What is 3 times 7?
21.
21. So didn't we say we could do this? Right? So why do you think I want to show this sort of work for this section? Because what is 3 over 3? 1. And it actually shows you why we could, right? Why this whole thing simplifies to 5 over 7. Nicely, doesn't it? You can see how you get 3 over 3, right? Yes. So when you do your homework for tonight, obviously these simple ones, you could just sort of, you don't have to do it that way, but is it always going to be this simple for your homework tonight? No. So you might want to do it this way. It's just sort of, it's going to be helpful, okay? The same thing as dividing top and bottom by 3, but we're showing work this way. Is that okay? Okay. Does that make sense? All right. So let's move on. So let's continue on. Now, instead of just having numbers, we have some variables in them. 16x over 18x, okay? Anybody know? By the way, what goes into both 16 and 18? 2. So could we use that fact, knowing that 2 goes into 16 and 18, and rewrite them as product of some fractions? 2 over 2 times what? 8 over? 2 over 2 times what? 8 over 9, right? Right. And then x over x. Is that right? Could we rewrite it this way? If you don't believe me, what is 2 times 8? 16. What's 2 times 9? 18. And I knew, because I knew that 2 goes into 16 and 18, I knew that I could do it this way, right? Isn't that right? Basically the same thing as dividing top and bottom by 2, isn't that right? So what do you think the answer is? Aiden?
8x over 9x.
8x over 9x. Now, what is x over x then? 1. Also, isn't that right? So 8 over 9 is simply 8 over 9. Now, if you write it this way, 8 over 9, you will get half credit.
What about the x?
What about the x?
Oh, that's 1.
Okay, x over x is 1, right? But if you give me the answer as 8 over 9, like I said, you will get half point, which a lot of people did on the test. What have I forgotten?
X.
What about x? X is there. X over x is 1. But whenever there's a variable in the denominator, but there isn't any, right? Very good. But there isn't any, right? But we had our original expression had variables in the denominator, didn't it? So what do you think we got to do here, Patty?
X cannot equal 0.
Exactly. We need to write down x cannot equal 0. Please be careful. So even if the answer comes out to be, right, just a number, even though there isn't any variable, but because we had, our original expression had x in them, you have to write down the restriction. How many people forgot to write down the restriction for the test?
Probably.
There was some, remember anyway, don't do that next time. But for tonight's homework, they're going to be really, really nice. They're going to say something like this. What do you think this means? Assume that no denominator equals 0. You're going to like this statement. Why do you think this statement is nice? Michael? You don't have to write restrictions. So in this section, they're going to say, assume that no denominator equals 0. So when
like the restriction is not, like it's another number, it's not.
So you only write down the restriction whenever there's a variable, right? But for this section, they're gonna say this. So and you're gonna like this because again, you don't have to write down the restriction. Is that okay? So for example, if we saw this earlier, right, in example 2, and if it said this, all you have to do is write 8/9. If it wasn't there, guess what? You have to write the restriction also. Do you understand? Okay, even though you don't see any x, right, on the denominator at the end, right, because our original expression had x in them, right, you have to still write it down. Is that okay? Any question? Dana? Yes, I will be clear in terms of where you have to. So if I don't say anything like, if I don't say this, assume that no denominator equals 0, then guess what? You have to write the restriction. Only time you don't write is if you see this. Is that okay? So that should be clear to you. All right. So take a look at example 1. A to the n times. So this is not example 1. I'm sorry. This is a review. How many people remember the rules for multiplying these powers with same base? Bella? That's exactly right. You guys remember this?
Yes.
You had the exponents, right? We need to know this to do some of the other ones. So I'm just sort of reminding you, this is what we learned before. Okay? And also, when you... Okay, let me move it up. Yeah, so, well, I had n first. So, but for addition, it doesn't matter which order you add. If it was a subtraction, even if it's alphabetical, you can switch it around, right? That'd be wrong. Okay, let's move it up a little bit. Also, I want to remind you that when simplifying powers, you know, the ones that we had before, like something to some power, some exponent, when you simplify, the exponent must be, anybody know? Whenever you have these powers, when you simplify, the exponent must be, yeah, Dana? Positive is correct. Turns out, whenever you simplify, if you didn't know, write this down. Whenever you simplify these exponents or powers, you know, at the end of simplification, you must have the positive exponent. Okay? You cannot have negative exponent. Then you're not done simplifying. Is that okay? So please keep that in mind. All right. Libby, does that make sense? All right. So knowing this, let's do some examples. Okay. And now, since our topic is dividing monomials, we have a monomial over a monomial, so we're dividing monomials. We have 8 to the 4th over 8 to the 3rd. Could we use that one that I just showed you, a times n times 8 times m? I mean, a to the n times a to the m. In other words, could we add the exponents in this? No, we can't. We can't add them yet, right? Chuck, what did you say? Hold on to that thought. Okay, so we cannot use the rule that we saw before, right? This is not multiplying monomials together, right, with the same base. We're now dividing, right, these powers with same base, correct? So when in doubt, you should write it out. So 8 to the 4th power means how many a's do I have on the numerator multiplying? 4 of them. How many a's do I have on the denominator? 3 of them. So now knowing that fact that we just learned, could we rewrite them as product of a bunch of fractions? Could we rewrite them as a over a times what? A over a times a over a times a over, is it a or 1? Right? It can't be a because then you would have 4 a's on the denominator. That's not what we have. Does that make sense? Do you see why I showed you that fact? Right? You could separate them as, right? You could rewrite them as product of fractions. So what's a over a, by the way? 1. So what's the answer? A. Okay, because you just simply get 1 times 1 times 1 times a, which is a. Question?
Couldn't you also like just cross them out, like
Yeah, that's what. Yeah. Why do we cross them out? See, I'm showing the work in terms of why we cross these things out. It's because what you have a over a, which is 1. When you're crossing them out, what does that become? It becomes 1. You see how I'm showing that algebraic work here? That's why it's important. Yes. Good. Turns out there's a shortcut for these. Notice we have to have the same what? Base, right? And Chuck said it also, right? Chuck said, well, can't you just subtract them? It turns out you could actually, that's a shortcut, so write this down. So this is a shortcut. Turns out if you have the same base, all you have to do is subtract the exponents. If you have these, right, powers with same base and you're dividing them, right? All you have to do is subtract. It sort of makes sense, right? When we were multiplying these, we added the exponents. Guess what? When we divide them, we subtract the exponents. Very good. So a lot of you saw that already. Okay. Yes, sir.
What would happen if you're dividing exponent that has a lower amount of power than the denominator?
That's actually what I'm going to do right now. Very good question. The question is, what happens if the exponent on the bottom is bigger than the exponent on the top, right? So what are we going to do? So we'll get there. Just wait. Okay. Yeah. Question.
Would for like a question like this, would we have to write any restrictions?
Good question. Do we need to write down the restriction? No. Why not?
Because it says
I said all the denominator is what? Yeah. None of the denominators are. Assume that what? No denominator is equal to 0.
But will we get questions like this where it doesn't say that?
Yeah. If it doesn't say it, then guess what? Your restriction will be a cannot be 0. Okay. Is that clear?
Yeah.
All right. So let's then move on. And you guys asked this. You guys read my mind. I was going to actually show you here. Look at this one. So by the way, before I get to the example, can I just show you that a over m, I mean a to the m over a to the n, where they have the same base. Would this work if they don't have the same base?
No.
No. This rule doesn't work, right? Just like the other one, right? Whenever you have these rules, they have to have the same base. What does this equal to? A over m. I mean a to the m over a to the n. Claire, what do you think? It equals to?
It equals to a plus a m.
No, we just talked about. Look at the previous example we just did. If they have the same base and you're dividing them, what do we do with the exponents?
We divide the exponents.
Nope.
No.
We subtract them because when we're multiplying them, we added them, right?
Right.
So it turns out when you're dividing, then you subtract. So write that down. That's the rule. Okay, now let me give you the example that you're talking about. What happens if the exponent on the denominator is bigger than the exponents in the numerator when they have the same base? Okay. So take a look at this example. It's very similar now. Instead of having a to the 4th on the numerator, now I have a to the 4th on the denominator. Do you think that rule still applies on this?
No.
Actually, it does.
Yeah.
Because that rule doesn't say anything about, right, the exponents being smaller or larger, right, in the numerator. So what would this come out to if you follow the rules? Royce?
1 over 8.
No, just looking at, okay, you're right. A lot of you are sort of ahead of me. But just following the rule, what do we do with the exponents again? We subtract. So we get a to the 3rd what? Minus 4. What is that? A to the negative 1, right? By the way, do you guys remember? We're good. Do you guys remember what I told you about exponents being negative? Is this simplified? Yeah, we can't. That's not. Well, you could have it, but it's not simplified. So we're not simplified, right? So this is okay, but you know it's not simplified. So how do I make it so that this becomes positive? Yeah. Yeah. It turns out the answer is 1 over a. But why? How does that become? When in doubt?
Write it out.
Okay, so how many a's do I have on the numerator?
1.
No. I have a to the 3rd over a to the 4th. Let's just write it out since we don't really understand why it's 1 over a, right? So, how many a's? How many a's on the denominator?
3.
Denominator of 4. So isn't it a over a, right? Times a over a times 1 over a?
Yeah.
correct? What's a over a? 1. What's a over a?
That's
Easy.
So this is 1, right? So you just get 1 over a as your answer. So it turns out a to the negative 1 power means what? 1 over a. It becomes a fraction. It becomes 1 over that power without that exponent. Do you see that? Samuel, question? So do you see how a over negative 1, a to the negative 1 power became 1 over a? Right? I just showed it to you, right?
Yeah.
Alright, what if, let's see if you, what if somebody asks you, what if I had a to the negative 4? Anybody want to take a wild guess as to what this means? Christina, what do you think?
Make it a over 1.
Hint, look, I had a to the negative 1 power, right? By the way, does this become negative a? Is this same as a times negative 1? Is a to the negative 1 power same as a times negative 1? No. Okay, please. Many times people see this and they go, oh, don't I multiply negative 1 times a? No, that's not what it means. It means a to the negative 1 power, right? So what do you think? So if a to the negative 1 power became 1 over a to the first, anybody want to guess what a to the negative 4 power? Christina, try it again.
1 over 8 to the 4.
You got it. 1 over a to the 4.
Oh, I do that one.
So, in general, turns out, guys, this is always true. Write this down. It turns out that if I have a to the negative nth power, guess what this would be? Go. Oh. Go ahead and discuss with your group. What do you guys think? I'll wait. What do you think this will be? Okay. Guys, look. We said that a to the negative 1 was 1 over a to the first, right? We actually wrote it out, right? So, guess what? A to the negative 2 is 1 over a to the second. Guess what? A to the negative third is 1 over a to the third. Guess what? A to the negative 4 is
1 over 8 to the 4.
yeah. And so guess what? A to the negative n is 1 over a to the n. Okay. Does that make sense? Right? Do you see the pattern?
Yes.
No? We're just following the pattern here. You're right. I haven't really explained why this is true. Correct? And now let me try that. Okay, let me show you why this is true. Is that okay? Okay? So take a look at. So let me ask you this. Okay, so take a look at this first and you could write this down a little bit. But I want you to follow along. Okay, Samuel? So what does a to the third power mean? It means x times, not a. X to the third power means x times x. How many x's? 3. Multiplying all together. Would you not agree?
Yeah.
Okay, what about x to the second? X times x. Right? What does x mean? X to the first. Just x. Now, does anybody see what we're doing as we're decreasing the exponents? What's happening to the number of x's? Right. And how are we going from the first step to the second step? What operation am I taking? In other words, how does x times x times x become x times x? We're dividing by what? We're dividing by the same base, which is x. Isn't that what we're doing? Would you not agree? If you divide x times x times x, right? If you have 3 x's like this, you divide it by x, don't you get x times x? And what's x times x divided by x again? Isn't that x? Yes?
What is x to the 0 from?
Excellent question. Guess what I'm going to ask you next? What do you think? So I want you to all think as a group. If this is what's happening as we're decreasing the exponent by 1, we're dividing by x. Isn't that what's happening? What do you think that x to 0 power means? Go ahead, everybody discuss with your group. This is exactly what I wanted you to think about. How many people think the answer will be 0? Because I saw some of you think. Oh, few of you. Okay, so let me ask you this. We're dividing by x, right? What's x divided by x? Is it 0? No, it is 1, guys. So it would not be 0, it's 1. Okay? Do you see how we're just dividing by 0? Of course, x cannot be 0. Because if x was 0, you'll be dividing by 0, which will be wrong, right? Does that make sense? Now, we're not going to stop here. We're going to go, what is 1 less than 0?
Negative
Negative 1. So guess what you would get if I have x to the negative 1 power? You have to divide 1 divided by x, right? What's 1 divided by x?
1x.
Is it 1x? 1 divided by x. What does division mean? Dividing means multiplying by the reciprocal. So what does 1 divided by x mean? It means 1 times? What's the answer? 1 over x. Do you see how x to the negative 1 power becomes 1 over x to the first power? You can think of it that way. Guess what x to the negative 2 will be? 1 over, if you divide, yeah, you're going to divide 1 over x by x, right? What would that mean? That means 1 over x divided by x is the same thing as 1 over x times 1 over x again, right? Dividing by x is the same thing as multiplying by the reciprocal. So what would you get? 1 over x to the negative 2 will be 1 over x squared. Does that make sense? Right? Questions? You're basically dividing by x. Isn't that how we get 1 for x to the 0 power? And 1 over x for x to the negative 1 power? Now, would it work for numbers? Sure. 3 to the third power, right? It means 3 times 3 times 3. Right? Guess what 3 to the second power means?
3 times 3.
Yeah, and aren't you dividing by 3 from previous? 3 to the first is simply 3. What's 3 to the 0 power then?
1.
It'll be 1. Right? 3 divided by 3 is 1. What is 1 million to the 0 power? Yeah, guys. It'll be 1. What is negative 3,000 to the 0 power? 1. But can we have 0 over 0 to the 0 power? No, that means you're dividing by 0, right? Because if you're dividing by that base, so you can't have you cannot have the base equal to 0. Therefore, 0 to the 0 power is undefined. Is that okay? All right, what about 3 to the negative 1 power? 1 over 3. Let's move on. What's 3 to the negative 2 power? You divide 1/3 by 1 over 3, right? The same thing as dividing by 3, correct? Dividing by 3 is same thing as multiplying by the reciprocal, which is 1/3. So you get 1 over 9, which is 1 over second. I mean 3 to the second. 1 over 3 to the second. And so on. So do you see how this works? X to the negative 1 power is 1 over x to the n, right? 3 to the negative n power, of course, then is 1 over 3 to the n. Do you guys see this? Okay. Write this down then. Okay. I'll wait. So is this always true? X to the 0 power is equal to 1?
Yeah.
No, that's how I get it wrong. This will not be always true. You have to say what? Except x, yeah. So where x doesn't equal to 0. If x is 0, then you're dividing by 0 because you're dividing by that base. Okay. So you want to make sure that the base that you're dividing by isn't 0. Okay. And so knowing these, we can actually do some of the dividing these monomials. Okay. So, any question? May I move on? Let's do some examples then. Okay. We'll start with a review. Okay. Do you guys remember finding GCFs? Okay. So and again, I did the first step for you, the factor tree. By the way, on your homework, are they going to do this for you? No. Okay. You have to do it yourself. Now, why do we do all this work? And why is this nice? You could literally see your common factors, right? That's why we do the prime factorization, right? And we write them in exponential form. Claire, what are the common factors?
2 to the second.
Oh, just give me the common factors first. We'll do the exponents in a minute. What are the common factors? You can see them, right?
Yeah.
What are they?
2, 3, and 5.
Exactly, 2, 3, and 5. It's easy to see because you could literally see it, right? So, and which exponents do we choose? 2 to the third or 2 to the second? 2 to the second. We want to make sure it goes into both of these numbers, right? So you have to choose the smaller exponents, correct? 3 to the what?
First.
And 5 to the
Second.
second. And it turns out, right, choose the smaller exponent. When it turns out that when you multiply these together, you get 300. Any question? This is a review, isn't it? Okay. Remember, step 2 is you choose the smaller exponent, right, of the common factor. Knowing this now tonight's homework, do you think they're gonna give it to you like this? No, it's going to be a little bit different. Now let me show you sort of the homework question you will get. Okay, here. It's the same exact one, except now guess what? We have some variables. And turns out when they give you variables, it's actually nice because look, all these variables are already written in what kind of form? Exponential form. Isn't that nice? So, right, these variables, do you have to do a factor tree for these variables? No, it's already written in exponential form. You don't have to do any factor tree. But do you think they will give you these numbers like this nicely as factors? No. Okay, you have to do that right yourself. You have to do the factor tree. So now, can you find me the GCF for these? Can you literally see the common factors now? What are they? Sammy?
Oh, no, I have a question.
Yeah, question.
After 1 to the 3rd, is that z to the 4th?
Yeah, so z to the 4th right here. And then you got x to the 1st, y to the 2nd, z to the 5th, t to the 6th. So who could tell me what common factors are? You should be able to just see them, right? What are they? Chuck?
X to the first.
Oh, let's do the numbers. Even though the numbers are same. 2.
2 to the second.
No, don't give me the exponents yet. 2, what else?
2, 3, 5.
Uh-huh. X.
X, Y, and Z.
Yeah. 2, 3, 5, x, y, and z are the common factors, right? Now, which one do we choose? Which exponent? Smaller one or the bigger one?
Smaller one.
Go ahead, everybody finish. I'll wait. Okay, how many people got 2 to the 3rd, 2 to the 2nd, 3 to the 1st, 5 to the 2nd, x to the what power? First, because you have x to the 2nd, x to y to the 3rd or 5th?
Third.
I'm sorry, 3rd or 2nd?
Oh,
2nd. Z to the 4th or z to the 5th? 4th, smaller exponent. What about t? That's not a common factor. So how many people got 300x y squared z to the 4th? Do you see how it's very similar to what you did last time? Now we just have some variables. Turns out it's easy to have when these variables are there because they're already factored, right? They're already written in exponential form. Does that make sense? Any questions? Do you see how it's very similar? Good. Let's do the last question now. So now for this example, we're going to learn all the ones that we learned so far in this lesson. We're going to put everything together. Is that okay? Yeah. So all the things we learned. Okay, so here is the example. It says, simplify this. 35 x to the 3rd, y, z to the 6th, all over 56 x to the 5th, y, z. And so thinking back from beginning of the lesson today, what do you think we should do first? Do you think we should, what should you do? Matthew? Yeah, before you subtract the variables, what should we do? Separate them. Thank you. Remember the first fact we learned? How are we going to separate these? Jason?
Oh, you did 35 over 56.
Good. Times?
Times x cubed
Right.
over x to the 5th.
Good.
Times y over y
Mm-hmm.
times z to the 6th over z.
That's exactly what I'm going to do. You see that? And I even wrote down the invisible ones because I know what I'll be doing with these exponents. What would I be doing, Claire? With these exponents when they have the same base and you're dividing them, what do we do with these exponents? Very good, you subtract them, right? Do we know how to simplify 35 over 56? Yeah, you better all know how to do that. Okay, go ahead, everybody, finish it. I'll wait. And by the way, can you have negative exponents when you're simplifying at the end? No. Okay, that's not allowed, okay? Please keep that in mind. That's why I said it's sort of combination of all the things that we learned today. Go ahead, everybody try. And help each other out. You can work as a group also, okay? Go ahead. First of all, 35 over 56. What goes into 35 and 56? 7. So you know what? I even did it this way. Remember how I separated them? I even did it like a factor tree. Do you have to do that? If you see it, that's no, you don't have. So I did it like this: 7 over 7 times 5 over 8. Is that okay? Or you could just divide top and bottom by 7. That's fine. Okay, so you get 5 over 6. How many people got 5 over 6 so far? Good. What about x to the 3rd over x to? 5 over 8. What about x to the 3rd over x to the 5th? You use the rule and you subtract the exponents. X to the negative second. I even showed all this work and you get x to the negative second. Y to the 0. Z to the 5th. What does, let's see, x to the negative 2 mean? 1 over x to the 2nd. What does y to the 0 mean? 1. How many people got this and got the answer as 5 z to the 5th over 8 x to the 2nd? Raise your hand.
I'm a winner.
If you got this, then you're ready for your homework tonight. Okay? If you didn't, go ahead and fix it. Any questions? Do you understand? Okay? Oh, good question. Class, do we need to write down the restriction? So if it said on your homework, assume that no denominator is 0, then you don't need to. If it did say it, then guess what? You have 3 restrictions. X cannot be 0, Y cannot be 0, or Z cannot be 0. Is that okay?